When we search for a single method that provides an answer for all the data, we find that neither primitive nor the most conventional machining methods provide the answer. Consequently, we are forced to consider methods that are cutting edge technologies even in our own time. That is insane. That literally means that all theories that have been propped up to this point make no sense. And all available technology in our modern society today make no sense. What? Like, mind blowing. Welcome to the journey. May this space inspire you to ask questions, explore the unknown, and most importantly, to awaken. This is the Library of Awakening. Alrighty, Library of Awakening family, what is going on? Welcome back to another video breakdown. This is going to be part 2 of the Giza power plant read chapter 4, picking up where we left off from the previous video breakdown. So we had covered a couple of pages in the previous video. We're literally just going to pick up where we left off to try and finish chapter 4 today. Well, then hopefully we can roll over into chapter 5 and later, video breakdowns. So welcome back. We really do appreciate the love and the support. I cannot thank you guys enough coming over here on the Library of Awakening YouTube. We have smashed through 300 subscribers. So thank you all so much for the love and the support. As we mentioned, there are over 60% of our viewers, whether it's you're watching the shorts, whether it's you're watching the video reads, that are not subscribed to the Library of Awakening YouTube. So if you guys are not subscribed and you're watching this right now, pause this video, do me that favor. Make sure that you guys are subscribed to the platform, as we're making uploads every single day, whether they're shorts or long video reads, going thoroughly through this valuable information in these books that go relatively unnoticed to the masses. And then also make sure that you smash that thumbs up button if you enjoy today's read, as it does help boost the algorithm and push these video breakdowns out to more like-minded individuals like yourselves. Remember, all the books that we read here in the Library of Awakening can be found within the private CyberX Discord. In the Library of Awakening section, there is literally hundreds, if not, honestly, at this point, not even exaggerating, thousands of books within the CyberX Discord. Ancient books that you probably couldn't even get your hands on anymore because they don't make them in print, all can be found within the CyberX private community. You guys can always head over to cyberxtrading.com. You can tap in with us and you can access this vast arsenal of valuable information yourselves. With that being said, let's pick up where we left off in the previous read. So we had finished off on page 108 in the Giza power plant. Starting off here, it goes on to say, today, these saw marks would reflect either the differences in the aggregate dimensions of a wire band saw with the abrasive or side-to-side movement of the wire, or the wheels that drive the wire. The result of any of these conditions is a series of slight grooves. The feed rate and either the distance between the variation in length, or the feed rate, the feed rate and either the distance between the variation in length of the saw or the diameter of the wheels determine the distance between the grooves. The distance between the grooves on the coffer inside the king's chamber is approximately 0.050 inches. Along with the evidence on the outside of the king's chamber coffer, we find further evidence of the use of high-speed machine tools on the inside of the granite coffer. The methods that were evidently used by the pyramid builders to hollow out the inside of the granite coffers are similar to the methods that would be used to machine out the inside of components today. Two marks on the coffer's inside indicate that when the granite was hollowed out, workers made preliminary roughing cuts by drilling holes into the granite around the area that was to be removed. According to Petrie, those drill holes were made with tube drills, which left a central core that had to be knocked away after the hole had been cut. After all the holes had been drilled and all the cores removed, Petrie summarized that the coffer was then hand-worked to its desired dimensions. The mechanists on that particular piece of granite once again let their tools get the best of them, and the resulting errors are still to be found on the inside of the coffer. Mind you, again, there aren't a lot of pictures here, but you guys can always just go Google pictures of they call it the, tomb inside the king's chamber. It's not a tomb, the coffer box inside the king's chamber. There's thousands of pictures on Google. You guys can go look at all this stuff yourselves. It's very interesting to say the least. Hopefully, one day I can actually go and see this stuff in person. I'm actually planning a trip to go to Egypt in 2027, which is going to be phenomenal. As Petrie noted on the E inside or the east inside is a portion of a tube drill hole remaining where they had tilted the drill over into the side by not working it vertically. They tried hard to polish away all that part and took off about 1/10 inch thickness all around it. But still, they had to leave the side of the hole 1/10 deep, 3 long, and 1.3 wide. The bottom of it is 8 or 9 below the original top of the coffer. They made a similar error in the north inside, but of a much less extent. There are traces of horizontal grinding lines on the west inside. This is kind of what it looks like, right? The errors Petrie noted are not uncommon in modern machine shops and I must confess to have made them myself on occasion. Several factors could be involved in creating this condition, although I cannot visualize any one of them being a hand operation. Once again, while working their drill into the granite, the machinists had made a mistake before they had time to correct it. Let us speculate for a moment that the drill was being worked by hand. How far into the granite would the Egyptian craftspeople have been able to cut before the drill had to be removed to permit cleaning the waste out of the hole? Or to permit, let me reread that. I'm not going to edit any of these videos anymore. I'm just going to read thoroughly through it. So you guys are going to get all the bloopers, all the mispronunciations of words. It's just going to be raw. How far into the granite would the Egyptian craftspeople have been able to cut before the drill had to be removed to permit cleaning the waste out of the hole? Would they be able to drill 8 or 9 inches into the granite without having to remove their drill? It is inconceivable to me that they could have achieved such a depth with a hand operated drill without the frequent withdrawal of the drill to clean out the hole, or without their making provisions for the removal of the waste while the drill was still cutting. By frequently withdrawing the drill, however, they would have been able to expose their error and notice the direction their drill was taking before it had cut a 0.200-inch gouge into the side of the coffer and before it had reached a depth of 8 or 9 inches. The same situation applies as easily with the drill as with the saw. A high speed operation made an error before the operators had time to correct it. Although the ancient Egyptians are not given credit for having the wheel, the fact is that archaeological evidence, when elevated or evaluated with a machinist's eye, proves that they not only had the wheel. Let's reread that. That's actually a really great sentence right there. Although the ancient Egyptians are not given credit for having the wheel, the fact is that archaeological evidence, when evaluated with the machinist's eye, proves that they not only had the wheel, but they used it in very sophisticated ways. The evidence of lathe work is marked distinct on some of the artifacts housed in the Cairo Museum, as well as those that were studied by Petrie. And if the Egyptians indeed used a lathe, then they had developed the wheel for the products turned on a lathe, being circular, have the elements of being wheels. In fact, the wheels that are used on locomotives are turned on lathes. So, although the lathes used by the ancient Egyptians have long disappeared, Petrie was very clear that they had existed when he identified the marks of true lathe turning on 2 pieces of diorite in his collection. It is true that intricate objects can be created without the aid of machinery, simply by rubbing the material with an abrasive, such as sand, or using a piece of bone or wood to apply pressure. The relics Petrie was looking at, however, in his words, could not be produced by any grinding or rubbing process which pressed on the surface. The simple rock bowl shards Petrie was studying would hardly be considered remarkable to the inexperienced eye. However, Petrie, devoting as much care to the observation of this artifact as he did to others, found that the spherical concave radius forming the dish had an unusual feel to it. Upon closer examination, he detected a sharp cusp where 2 radii intersected, indicating that the radii were cut on 2 separate axes of rotation. I have witnessed the same condition when a component has been removed from a lathe and then worked on again without being recentered properly. On examining other pieces from Giza, Petrie found another bowl shard that had the marks of true lathe turning. This time, though, instead of shifting the workpiece's axis of rotation, second radius was cut by shifting the pivot point of the tool. With this radius, they machined just short of the perimeter of the dish, leaving a small lip. Again, a sharp cusp defined the intersection of the two radii. While browsing through the Cairo Museum, I found evidence of lathe turning on a large scale. A sarcophagus lid had distinct lathe turning marks. The radius of the lid terminated with a blend radius at shoulders on both sides. The tool marks near these corner radii were the same as those I have observed when turning an object with an intermittent cut. The tool is deflected under pressure from the cut and then relaxes when the section of the cut is finished. When the workpiece comes around again to the tool, the initial pressure causes the tool to dig in. As the cut progresses, the amount of dig in is diminished. On the sarcophagus lid in the Cairo Museum, tool marks indicating these conditions were exactly where one would expect to find them. Egyptian artifacts representing tubular drilling are clearly the most astounding and conclusive evidence yet presented to indicate the extent to which machining knowledge and technology were practiced in prehistory. The ancient pyramid builders used a technique for drilling holes that is commonly known as trepanning or trepanning. Hopefully, I'm pronouncing that correctly, probably not. This technique leaves a central core and is an efficient means of hole making. When making holes that did not go all the way through the material, the workers drilled to the desired depth and then broke the core out of the hole. Trepanning was evident not only in the holes, or trepanning, that Petrie studied, but on the core cast aside by the masons who had done the work. Regarding tool marks that left a spiral groove on a core taken out of the hole drilled into a piece of granite, Petrie wrote on the granite core number 7, the spiral of the cut sinks 1 inch in the circumference of 6 inches, or 160, or 1 in 60, a rate of plowing out of the quartz and feldspar, which is astonishing. After reading this, I had to agree with Petrie. This was an incredible feed rate, distance traveled per revolution of the drill for drilling into any material, let alone granite. I was completely confounded as to how a drill could achieve this feed rate. Petrie was so astounded by these artifacts that he attempted to explain them at 3 different points in one chapter of his book. To an engineer in the 1880s, what Petrie was looking at was an anomaly. The characteristics of the holes, the cores that came out of them, and the tool marks would be an impossibility according to any conventional theory of ancient Egyptian craftsmanship. Even with the technology available in Petrie's day, 3 distinct characteristics of the hole and core are illustrated in figures 21, make the artifacts extremely remarkable. And you guys can kind of see those here. A taper on both ends in the core, a symmetrical helical groove following these tapers, showing that the drill advanced into the granite at a feed rate of 0.10 inch per revolution of the drill, or a tenth of an inch. The confounding fact that the spiral groove cut deeper through the quartz than through the softer feldspar. It's pretty crazy. In conventional machining, the reverse would be the case. In 1983, Donald Rahn of Rahn Granite Surface Plate Company told me that diamond drills rotating at 900 revolutions per minute penetrate granite at the rate of 1 inch in 5 minutes. In 1996, Eric Leither of True Stone Corp told me that these parameters have not changed since then. The feed rate of modern drills, therefore, calculates to be 0.0002 of an inch per revolution, indicating that the ancient Egyptian drilled into granite with a feed rate that was 500 times greater or deeper per revolution of a drill than modern drills. Wow. I'm going to highlight that one right there. That was nuts. If you guys are still watching on this, do me that favor, smash that thumbs up button and subscribe if you guys enjoy this type of content. I love reading this stuff. This stuff is so astonishing to me because it's just physical proof that to some extent they are hiding information that exists out there, that we in our history come from something that is so phenomenally unexplainable. Why hide this type of stuff instead of express it and try and explain it? It's just mind blowing to me that more people don't know about this. The other characteristics of the artifacts also pose a problem for modern drills. Somehow, the Egyptians made a tapered hole with a spiral groove that was cut deeper through the harder constituent of the granite. If conventional machining methods cannot answer just one of these questions, how do we answer all three? For those who may still believe in the official chronology of the historical development of metals, identifying copper as the metal the ancient Egyptians used for cutting granite is like saying that aluminum could be cut using a chisel fashioned out of butter. That's good. What follows is a more feasible and logical method, and it provides an answer to the question of techniques the ancient Egyptians may have used in all aspects of their work. The fact that the feed rate evenly spirals along the length of the granite cores is quite remarkable considering the proposed method of cutting. The taper indicates an increase in the cutting surface area of the drill as to cut deeper, hence an increase in the resistance. A uniform feed under those conditions using manpower would be impossible. Impossible. Petrie's theory of a ton or two of pressure being applied to a tubular drill consisting of bronze inset with jewels does not take into consideration that under several thousand pounds of pressure, the jewel would undoubtedly work their way into the softer substance, the bronze, leaving the granite relatively unscathed after the attack. Nor does this method explain the groove being deeper through the quartz. It should be noted that Petrie did not identify the means by which he inspected the core, whether he used a metrology instrument, a microscope, or the naked eye. It also should be noted that Egyptologists do not universally accept his conclusions. In Ancient Egyptian Materials and Industries, A. Lucas takes issue with Petrie's conclusion that the grooves were the result of fixed jewel points. He wrote, in my opinion, to suppose the knowledge of cutting these gemstones to forth teeth and setting of them in the metal in such a manner that they would bear the strain of hard use, and to do this at the early period assigned to them would present greater difficulties than those explained by the assumption of their employment. But were there indeed teeth such as postulated by Petrie? Evidence to prove their presence is as follows. A cylindrical core of granite grooved around and round by a graving point, the grooves being continuous and forming a spiral with in one part a single groove that may be traced 5 rotations around the core. Part of a drill hole in diorite with 17 equidistant grooves due to the successive rotation of the same cutting point, equidistant. That's an interesting word. I think that's the first time I've ever said that one. Another piece of diorite with a series of grooves plowed out to a deep of over, or a depth, excuse me, of over 100 of an inch. Let's reread that. Another piece of diorite with a series of grooves plowed out to a depth of over 1/100th of an inch at a single cut. Other pieces of diorite showing the regular equidistant grooves of a saw. 2 pieces of diorite bowls with hieroglyphs incised with a very free cutting point and neither scraped nor ground out. But if an abrasive powder had been used with the softer copper saws and drills, it is highly probable that the pieces of the abrasive would have been forced into the metal, where they might have remained for some time, and any such accidental and temporary teeth would have produced the same effect as intentional and permanent ones. Lucas went on to speculate that the workers withdrew the tube drill in order to remove waste and insert fresh grit into the hole, thereby creating the grooves. However, there are problems with this theory. It is doubtful that a simple tool that is being turned by hand would remain turning while the artisans draw it out of the hole. Likewise, placing the tool back into a clean hole with fresh grit would not require that the tool rotate until it was at the workface. There also is the question of the taper on both the hole and the core. Both would effectively provide clearance between the tool and the granite, thereby making sufficient contact to create the grooves impossible under these conditions. In contrast, ultrasonic drilling fully explains how the holes and cores found in the Valley Temple at Giza could have been cut, and it is capable of creating all the details that Petrie and I puzzled over. Unfortunately for Petrie, ultrasonic drilling was unknown at the time he made his studies, so it is not surprising that he could not find satisfactory answers to his queries. In my opinion, the application of ultrasonic machining is the only method that completely satisfies logic from a technical viewpoint and explains all noted phenomena. Ultrasonic machining is the oscillator. Oh man, hold on. Oscillatory. There we go. Ultrasonic machining is the oscillatory motion of a tool that chips away material, like a jackhammer chipping away at a piece of concrete pavement, except much faster and not as measurable in its reciprocation. The ultrasonic tool bit, vibrating at 19,000 to 25,000 cycles per second or hertz, has found unique applications in the precision machining of odd shaped holes in hard, brittle material, such as hardened steels, carbides, ceramics, and semiconductors. An abrasive slurry or paste is used to accelerate the cutting action. The most significant detail of the drilled holes and cores studied by Petrie was that the groove was cut deeper through the quartz than through the feldspar. Quartz crystals are employed in the production of the ultrasonic sound, and conversely, in responsive to the influence of vibration in the ultrasonic ranges, and can be induced to vibrate at high frequencies. When machining granite using ultrasonics, the harder materials, quartz, would not necessarily offer more resistance, as it would during conventional machining practices. An ultrasonically vibrating tool, but would find numerous sympathetic partners while cutting through granite embedded right in the granite itself. Instead of resisting the cutting action, the quartz would be induced to respond and vibrate in sympathy with the high frequency waves and amplify the abrasive action as the tool cut through it. The tapering side of the hole and the core are perfectly normal when we consider the basic requirement for all types of cutting tools. This requirement is that the clearance be provided between the tools, non-machining surfaces in the workpiece, instead of having a straight tube. Therefore, we would have a tube with a wall thickness that gradually became thinner along its length. The outside diameter becomes gradually smaller, creating clearance between the tool and the hole, and the inside diameter becomes larger, creating clearance between the tool and the central hole. This would allow a free flow of abrasive slurry to reach the cutting area. By using a tube drill of this design, the tapering of the sides of the hole in the core is explained. Typically, this type of tube drill is made of softer material than the abrasive, and the cutting edge would gradually wear away. The dimensions of the hole, therefore, would correspond to the dimensions of the tool that the cutting edge, at the cutting edge, excuse me, would the hold on, let's reread that. Typically, this is the type of tube drilling is made of softer material than the abrasive, and the cutting edge would gradually wear away. The dimensions of the hole, therefore, would correspond to the dimensions of the tool at the cutting edge. As the tool became worn, the hole in the core would reflect this wear in the form of a taper. The requirement for advancing an ultrasonic tool into a workpiece is for the cutting edge of the tool to apply pressure to the workpiece, as the vibratory motion of the tool does the actual cutting. This can be accomplished in two ways. The tool can plunge straight down, or it can be screwed into the workpiece. We can explain the spiral groove if we select the later method as the most likely one used. It should be made clear that the rotational speed of the drill is not a major factor in this cutting method. It is merely a means to advance the drill and apply pressure to the workpiece. Using a screw and nut method, the tube drill could be efficiently advanced into the workpiece by turning it in a clockwise direction. The screw would gradually thread through the nut, forcing the oscillating drill into the granite. It would be ultrasonically induced motion of the drill that would be the cutting, or do the cutting, not the drill bit's rotation. The latter would be needed only to sustain a cutting action at the workface. By definition, this process is not drilling process by conventional standards, but a grinding process in which abrasives are caused to impact the material in such a way that a controlled amount of material is removed. The fact that there is a groove at all, let's just reread that. The fact that there is a groove at all in the valley temple core may be explained in several ways. An uneven flow of energy may have caused the tool to oscillate more on one side than the other. The tool may have been improperly mounted, or a buildup of abrasive on one side of the tool may have cut the groove as the tool spiraled into the granite. Another method by which the grooves could have been created was through the use of a spinning trepanning tool that had been mounted off center to its rotational axis. Clyde Treadwell of Sonic Mill Inc. explained to me that when an off center drill rotated into the granite, it would gradually be forced into alignment with the rotational axis of the drill's machine axis. The grooves, he claimed, could be created as the drill was rapidly withdrawn from the hole. If Treadwell's theory is a correct one, it still requires a level of technology that is far more developed and sophisticated than that in which the ancient pyramid builders are given credit for. Hmm. This method may be a valid alternative to the theory of ultrasonic machining, even though ultrasonics resolves all the unanswered, excuse me. This method may be a valid alternative to the theory of ultrasonic machining, even though ultrasonics resolves all the unanswered questions where other theories have fallen short. When we search for a single method that provides an answer for all the data, we find that neither primitive nor the most conventional machining methods provide the answer. Consequently, we are forced to consider methods that are cutting edge technologies even in our own time. That is insane. That literally means that all theories that have been propped up to this point make no sense. In all available technology in our modern society today, make no sense. What? Like, mind blowing. It goes without saying that further studies need to be made. One way to decide between opposing theories is to replicate the cores using the advanced machining methods I propose and the more primitive methods proposed by some Egyptologists. Following such a replication, the cores can be compared using metrology equipment and a scanning electron microscope in order to detect the microscopic changes in the structure of the granite that can result from the pressure and heat exerted or created by the tool. I doubt many Egyptologists share my conclusions regarding the pyramid builders' drilling methods, so it would be beneficial to perform these tests in order to prove conclusively the most likely method the builders used for cutting the stone. As this book was being prepared for publication, I received an unexpected email from Nova stonemason Roger Hopkins, who had read my article about ancient Egyptian technology on the internet and wrote, Dear Chris, you are a voice in the wilderness. I just finished your article about the stoneworking techniques in the ancient Egypt. I am a stonemason by trade, and in 1991, the BPS series Nova invited me to go to Egypt to experiment with building a pyramid. I quickly got bored with working the soft limestone and started to ponder the granite work. Here in Massachusetts, my specialty is working in granite. When I was asked by Egyptologists how the ancients could have produced this work with mere copper tools, I told them they were crazy and that they were using at least state of the art techniques. Wow. At first glance, I tend to agree with you about the ultrasonic core hole drilling. I do enough core hole drilling to know that the embedded scrape marks would not be the result of ordinary core drilling. I would love to explore this technique further with you and perhaps do a presentation in our next film about Egypt. In my subsequent communications with Hopkins, I found him to be very honest and straightforward regarding the techniques used by the ancients. His account of the building of the Nova Pyramid was much the same as the reported by Mark Lehner. He asked my permission to pursue the ultrasonic drilling aspects as it was my idea, and I told him the more the merrier. The more people who are looking into how the ancient Egyptians accomplished their prodigious feats, hopefully I'm pronouncing that correctly, the better chance we have of determining the truth. Moreover, like any good businessman, Hopkins sees the potential for applying this technology in his own work. My last email from Hopkins informed me that he had contacted people at the Massachusetts Institute of Technology about pursuing this theory and had received promising feedback, and he would keep me informed. So the chapter on ultrasonic drilling of the Egyptians' granite is at an end, and even as this story faces a new beginning. Wow, what an insane chapter. I think at the end of the day, no matter what theories are proposed, we can take away that to some extent, the ancient builders of the Great Pyramids had technology that we, even to this day, could not comprehend. And they had it thousands of years ago. So, absolutely phenomenal read. We're going to cut it here today. Next chapter we're going to read from this book. I don't know if we're going to read it in as the next video, but I do want to get into chapter 5. the amazing discovery at Giza, because this one is another mind blowing chapter in this book that I absolutely love and enjoy. So, with that being said, many blessings to you guys as always. Be cognizant, be aware out there. If you guys enjoyed this read, do me that favor, smash that thumbs up button, make sure that you subscribe to the platform, and I will see you guys in the next video breakdown. I know some of the perspectives that I share may be as challenging for you as they once were for me, but isn't that the beauty of exploration? Every perspective, no matter how unconventional, has something valuable to contribute to it if it's shared. Knowledge is not absolute. It's a living, breathing phenomena, shaped and reshaped over time. The important thing is not always be right, but to always be curious. Explore freely, share boldly, and learn deeply. And don't rely solely on others to validate your discoveries. Stand firm in integrity, even in the face of criticism. Remember that growth always means embracing the humility to admit when we're wrong. Learning from our errors is not a setback, it's the very essence of our progress. So, welcome to the journey. May this space inspire you to ask questions, explore the unknown, and most importantly, to awaken. This is the Library of Awakening,